Oakley dokley focalies. We're going to go ahead and jump on in. Got my pals here with me today. They're going to help teach the lesson. What do we have here? We have a linear equation. Looks like it's in slope-intercept form, which is what we've been doing this whole time. Now I'm going to do some math wizardry here, and for lack of a better term. And I'm going to turn this linear equation in two variables into a linear equation, into a linear function. Did not do what I was expecting. There we go. It's a linear function, a little delayed. Okay, so this is the same on a graph. It means the exact same thing. When you say y equals 2x minus 5 and you say f of x equals 2x minus 5, it's just another way to write the equation for the same line, except this is written as a linear equation in two variables, and this is written as a linear equation in function notation. And function notation is really cool because it gives a name to the equation, and its name is the letter that appears in front of it. So I'm going to be very, very clear right here. When you see this f of x, pretend that it's like a y, or g of x, or h of x, or a of x, or m of x. You can treat it like a y. It does not mean f times x. So you're probably thinking like, well, this is why I hate math, Mr. Slagle, because you tell me one thing when I put a letter next to a letter, it means multiplication. Now you're telling me when I put a letter next to a letter, it doesn't mean multiplication? That's correct. That's exactly what I'm saying. And, you know, we do that with the English language all the time. What is this word? Well, it depends. It depends on how it's used in context, right? If you were reading a book and it was like, Billy went out to the lake to catch he caught a bass. He caught a bass guitar in the lake? Why? What are the odds of that? What about a boot or a tire? The old cliches. He didn't catch a bass, caught a bass. Because you can read the sentence and you know that it's not bass. You know that it's bass. Similarly, if you were reading about a concert, you would know that they were not playing a bass solo. It would be a very hard instrument to play. Okay, so anyways, enough tiptoeing around what I'm supposed to be doing here. This does not mean multiplication in context. We can look at this, and so since it says f of x equals, we know, okay, this is function notation. We have a function, and that function's name, this is the function's name, the thing in purple. The function's name is f, okay? So we can call it, you might see ones that are named f, you might see ones that are named h, you might see ones that are named g. There are many options for what a function could be named. And in computer programming, they're not just letters, they can be entire words or even little phrases joined together. Okay, so function name, that is what the f is. And that's how we can reference it quickly. The x, this is our input. Okay, just like when we learned about the vending machine, you put in a code, you get something out when you're done. Well, with this, you put in these two x slots, or you put in here and then it shows up there. What our function does is our function takes our input and it multiplies it by 2, and then it subtracts 5 in that order, right? Order of operations. And then over here, this is kind of like what our function does, and ultimately what produces the result, the value of our function. So this is our function's value, or the process that it does. So what our function does, takes our input, multiplies by 2, subtracts 5. Okay, and sometimes you're going to see a function reference. You'll see this f of 4. Again, this doesn't mean f times 4. It means f composed of 4. So what we're going to do, it really asks a question. This asks the question, what is the value of the function f at x equals 4? It's a question. Now, we want to ask these kind of questions all the time in mathematics, and it's very fortunate that we don't have to say this big long sentence every time we're curious. We can just say, what's f of 4? Or, lots of other things. So, and by the way, it might be helpful to note this is read f of 4 for short. Okay, f of 4. Great. Now we know what function notation is. We got our name, we got our inputs, and we've got what our function does. Fantastic. Let's keep cruising. So let's use function notation. Let's use plotting points as a method for graphing. So I want you to I want to link all these things kind of together here. So I'm just going to pick a couple inputs. How about we'll start with an easy one, 0, then something negative like -4, and something positive like 3. We'll see what happens. So I'm going to take these inputs and I'm going to, one at a time, I'm going to shove them into the function, and then we are going to get out an output. So let's do them, the green ones, one at a time. All right, in green, it goes, I'm going to throw the input 0 into my function. So what I'm going to find here is, what is f of 0? F of 0, well, I just go to my function, and everywhere that there's an x, I replace it with a 0. So that's 2 times 0 minus 5, which is 0 minus 5, which is, hey, that is 5. Sorry, -5, super. This is, what is f of -4? Okay, so I can go here and I plug in 2 times -4, yada, yada, yada. You get the picture. I'll finish that in just a second. We plugged in the input 0. We got out the output -5. So out comes -5 from this function. So we input 0. We got out -5, and that corresponds to a point. Remember how I said, y and f of x kind of are the same thing? It's really what it is. Okay, so 0, -5. So I can go to my graph. And I can plot the point 0 on the x, -5 on the y. We know that that is our y-intercept, right? Because this is in sloped-intercept form anyways. This is an overly simplified example, but it's helpful to work, to do this really quick. So I'm going to finish up the rest of these points, and I'll keep my colors consistent for all you people that are as crazy as me about it. Okay, -2 times 4, that's -4 is -8 minus 5 is equal to -13. Yikes. And then down here, let's do f of 3 really fast. That's 2 times 3 minus 5. Again, all I'm doing is just substituting in here. 6 minus 5, which is 1. Oh boy. Hopefully I did my math right. Well, we're about to find out. We know that this is a linear function. So out pops -13. Out pops 1. All right, so let's go to here and let's write these gall darn points on the table. So -4, -13. Oh boy. -4, we're going to go down 1, 2, 3. Okay, there's one of my points. And the next one is 3, 1. Do those look like they're in a line? Golly gee, they sure do to me. And we can check. We know that the slope is 2, so I can go up 1 over 1, up 1 over 1. Yep. Down 2 over 1, down 2 over 1, down 2 over 1. Yep, we're good to go. So we've got our line. We can now connect our dots here. Connect the points. Add an arrow to the end. And we have graphed our line using function notation. So function notation, we put something in just like the vending machine, we get something out. Okay, so one great use of functions is it's easy to reference which equation we're talking about, right? If these all said y equals, we wouldn't be able to distinguish between them, and as mathematicians we wouldn't be able to talk about their different properties. But here I can say h, and then you know that I'm talking about this one, or g, and you know that I'm talking about that one, so on and so forth. So if I ask you to find something, let's do a couple of these. Let's do let's say h of negative 2. H of negative 2. Well, h of negative 2, I go up, I figure out which one's h. Oh, that's this one. H of negative 2, and I do 6 minus, and right where I just copy this, and everywhere there's an x, I'm going to put whatever I put inside h of negative 2. Okay, so that's 6 minus negative 2 is 6 plus 2, which is 8. Okay, great. Let's do another one. What is g of negative 5? G of negative 5. G of negative 5, well, I'm going to go to G, the red one, right? So in red, I'm going to do G of negative 5, which is negative 5 squared plus 22. So here, now careful, this is negative 5 times negative 5. These two things are not the same. So you need to make sure that when you're substituting in, you're thinking about it's this whole thing that's getting squared. So negative 5 squared, this is the opposite of 5 squared, which is negative 25. This is negative 5 times negative 5, and a negative times a negative is a positive 25, so just be careful. Whoops, try that again. Get out of here, line. All right, so it's 25 plus 22, which will give us 47. Great, 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 great. Fantastico. Okay, you guys can try this one. You tell me what is, on your own, what is f of 8 on your own? Tell me what f of 8 is. Okay, you can pause the video if you'd like. Okay, here we go. Moving on. So f of 8 is 1 half times 8 minus 2. Half of 8 is 4 minus 2 is equal to 2. Fantastic. You may also see some questions that look like this. It may say, hey, what's negative 3 times f of negative 12 plus 6? Oh, geez. Well, in this case, f of negative 12 is just some number, but we don't know what it is yet because we haven't sent negative 12 off to the function f. We got to be careful. So if we want to do something like this, you're at negative 3. I'm going to just kind of show you that this is sending off to the function. It's going off to here. I'm going to do 1 half times negative 12. Whoops. Try that again. Minus 2. I copied the whole equation, except I replaced x with what it is equal to there, plus 6. So PEMDAS, we got to do the inside the parentheses first. This will be negative 3 times half of negative 12. It's negative 6 minus 2, plus 6 gives us negative 3, and these things are all equal. I'm being a bad math teacher here. Negative 3 times negative 8 plus 6, which is negative times a negative is positive 24, plus 6 is 30. So sometimes you'll see expressions that involve computations with sending something to the function. Okay, and sometimes we see functions that, you guys aren't used to. What is this? I don't know. Like, what you guys, we've been seeing lines. What is going on here? Now, if you know how to square or multiply something by itself, you can figure this out. Everyone in here can figure this out. I didn't give you a rule for graphing something like this. It's not like slope-intercept form, right? But anyways, if you want to graph something like this, if we want to see what this looks like, function notation is a great way. You can use it to just pick points and plug in and try and figure it out. And I always encourage taking the path of least resistance, and by that I mean do math with numbers that are easy to do math with. So we want to figure out what this function looks like. It's not a line. It's not a straight line. You guys have probably never seen one of these graphed in your math class before. That's okay. So I'm going to find out what m is 0. I chose 0 because 0 is easy to do math with. So you go to your equation. We're going to do 0 squared plus 2 times 0 minus 6. Okay, that's 0 plus 2 times 0 is 0 minus 6 is negative 6. So we get the point 0, comma, negative 6. 0, negative 6. It's on our graph. 0 is really easy to do math with. Well, I'm going to switch colors. Now, whenever I am doing a graph like this, or whenever I'm graphing something and I don't know what it looks like, I always like to just move over just 1. And if it doesn't change a lot when I move over 1, maybe move over a little bit more next time. But start easy. So I'm going to find m of 1. That means on the x-axis, where is the value of my function when x is 1? So I'm going to go through here in red, and I'm going to do 1 squared plus 2 times 1 minus 6. That is 1 plus 2 minus 6 gives me 3 minus 6, which is negative 3. So I've got another point on my graph. Whoa, that is 1, negative 3. All right, this, okay, so, well, it looks like a line to me. Whoa, slow down. We only have 2 points. We got to get a couple more. All right, so let's go maybe 1 in the other direction and see what happens. Let's do m of negative 1. Let's do some math here. It's going to be negative 1 squared plus 2 times negative 1 minus 6. Oh my goodness gracious. Negative 1 squared, negative 1 times negative 1 is positive 1. 2 times negative 1 is minus 2, and then minus 6. Okay, wait a sec. Let's take a look at this. That's 1 minus 8, which is negative 7. So this is the point negative 1, negative 7. Negative 1 down to negative 7. All right, I know I did my math right. This is not a straight line. It's starting to curve a little bit. All right, well, let's keep trucking then. I know you guys feel free to fast forward here if you want to see how Snape kills Dumbledore. All right, let's see here. This is going to be negative 2 equals m of negative 2. Negative 2 squared plus 2 times negative 2 minus 6. That's 4. Minus 4 minus 6. Well, 4 and minus 4 is going to go to 0, so we get negative 6. So we get the point negative 2 comma negative 6. Negative 2 comma... What? Oh, now come on. Is that allowed? It can turn around? It can turn around like that? This is I don't think so. I don't think you're allowed to do that. Anyways, moral of the story here is, folks, did I do red? I did. I didn't do purple. So all the purple points, if I were to continue drawing or continue plotting points, which you will on your assignment, you're going to have to graph one that looks something like this. This is a very special shape. It turns out to be symmetric, and if I were to continue plugging in negative 3, I would get one here, I'd get a point there and there, and I would get a point, 7 plus 2, there and there. And there are points in between all these points as well, and what this graph looks like is, it's very hard to draw on my tablet, I apologize. It kind of looks like a nice rounded, I'm not doing, this is not very pretty, I realize. Okay, the shape kind of looks like this. Okay, it's a very special shape, and if I were to flip this upside down, it would follow the same path that this tape measure does when I throw it, or something very close in shape. This is this function is called a quadratic function, and it takes the shape of something called a parabola. It is naturally occurring, like the path of anything that is really affected by gravity is can usually somehow be modeled by a quadratic function. Pretty cool. Okay, so great. Yeah, that's what this is. We plugged in points until we got, and I could have kept going, but it would have gotten repetitive. I believe you can do that on your own. Okay, this function is a little more challenging, so I'm going to do a couple examples of what we're doing here. I know you guys have seen this before, but I'll do a quick review as to what it is and how you do calculations with it, and then you're going to try a couple on your own. I'll go over those. That'll be it for this lesson. Okay, here we go. There is actually another video on this that goes with the 3-2 assignment, but that's okay. It's 2 parts. This is 2 parts. So let's pick a couple numbers. So if I want to figure out the value of this function, Let's pick maybe r of, let's do something negative. We're going to do like r of negative 2. We'll start simple. Okay, first of all, what are these bars? We need to go over that. A quick review. Whenever you see these vertical bars in an equation or in an expression, it represents something called absolute value. Okay, this is an absolute value function. This is, so absolute value means distance from 0. And that's talking about distance from 0 on the number line. So if this is 0, and I say, hey, what's the absolute value of 3? Well, how far away is 3 from 0? How far away is 3 from 0? Well, it's 3 away, okay? And here's negative 3. How far away is negative 3 away from 0? Well, how far? How far is just a distance, and that distance is going to be positive. It's just 3. So the common mistake is people just change the sign. It's not changing the sign, it's asking the question distance, and distance is always positive. So, yeah, the distance is 3. They're 3 away. All right, so let's figure out what r of negative 2 is. So we would do 12 minus 3, and then here we're going to go 2 times negative 2 minus 12 and absolute values. Okay, 12 minus 3. So what you do, you guys are familiar with PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. You guys have probably seen that before. You may have heard of GEMDAS too, which is the parentheses is actually stands for grouping. So any sort of grouping, like brackets or parentheses, you do inside those first before you do anything else. So that's what we're going to do. 12 minus 3 times, and then here we got to simplify. Multiplication has to happen before subtraction, so you'll get minus 4 minus 12. I'm going to have to do math here. 12 minus 3 times negative 4 minus 12 is negative 16. Okay, and then the next step is to take the absolute value. So we cannot multiply these yet until we figure out and we answer the question, how far away is negative 16 from 0? So we're going to do 12 minus 3 times, well, it's 16 away. So that turns positive. You end up with 12 minus, what is that? 32, 48. 12 minus 48. And 12 minus 48 is negative 36. So that's how absolute value works. Okay, you can plug in any old thing and you'll get something out when you're done. You guys go ahead and try these two, and I'm going to go over them in just a second. You guys try those on your own, and then you can unpause the video. So here we go. N of 12 is equal to the absolute value of 5 minus, minus 12. Okay. Minus 12 and absolute value minus 6. Keep going. 5 minus 12 is negative 7 minus 6. How far away is negative 7 from 0? Well, it's 7, so 7 minus 6 is 1. So the value of n at the x value 12 is 1. Okay, let's do negative 3. You guys can try that on your own if you'd like. 5 minus negative 3. And absolute value minus 6. 5 minus negative 3 is really 5 plus 3 minus 6, which is equal to the absolute value of 8 minus 6. Absolute value of 8 is 8, minus 6 is 2. Fantastic. I think that's it. All right, that's the end. That's this video, and there will be another video on function notation. I'm going to go over some more complex things that you can do or things you talk about with function notation. So we'll see you at the next one.